Hey, so in this lecture I want to discuss functors or function objects. Now we have discussed how we can overload the function call operator before. Okay, it is considered a binary operator, the list of arguments passed in is considered the second operand, and we have an example of the function call operator member function declaration here. Now a functor or a function object is an instance that can be invoked like a function, and the functionality is set up by overloading the function call operator. The advantages of functors over functions, now not function pointers but functions, are that functors can have a state. Okay, they can have members that can change and update during program execution, and a functor is defined as a type, and therefore they can be used as a template type parameter. I'll demonstrate how this is useful and why this is important in later examples. As a simple example of a functor, I have the square functor right here. We overload the function call operator. It accepts an integer and we can return the square of that. We return the parameter multiplied by the parameter. A functor can also have a state. You can see in this case we have a member. It can be constructed by passing in a member. Let's say you want to do a binary operation, then you have some member that you can pass in to add. And then with the function call operator, you can see this is going to return the member plus the parameter that we pass in. We will see examples of that later on in the lecture. Then I have a regular function, square function here, which is also going to return the parameter times the parameter. In the main function, I go and instantiate the square functor here, and then I go and do console output statements. Square I pass in 5, and square funct and I pass in 5, which will use the overloaded function call operator. Build around that. It will print out 25 twice. Also, let's say I have an overloaded function call operator to print something out, for example, or that takes in different types. Of course, what you can do is you can go and have multiple overloads of the function call operator. Let's say one takes in a float, one takes in a double, and so on. You can have a print functor that prints different things out, which can be a time saver as well. And of course, you can save that maybe in a header file. Alright, so this is just a basic example of what a functor is. As you can see, we can invoke it here in a similar way to how we would invoke a function, or indirectly using a function pointer as we've seen before. Next, we've seen this example before. I have a void display function which takes in an integer and it's going to print that out, doing a tab following the printout of the parameter. And then I have this print scores function. The formal parameters are an array, so it's going to take in an array. We don't want to modify the element, so this is going to be int const because we simply want to print those elements out. Then it's going to take in the size of the array. The third formal parameter is a pointer, a function pointer that returns void and that takes in an integer. So I'm going to print out the scores are, and in the for loop I'm simply going to print out the scores by invoking the display function indirectly. So whichever function we specify in the argument that matches the signature and return type of what we have in the formal parameter for the function pointer. Okay, so we invoke that function indirectly through the function pointer. We pass in scores parameter and we pass in I, the iterator, to fit that particular element. And I do an end line. Okay, in the main function I have a constant integer array size and I initialize that to 5. I have a scores array, I pass in array size. I specify some elements explicitly here, the first 3 elements. And then I print those out using the print scores function. I pass in the scores array, simply passing in the identifier of the array size for the second argument, and then display, which again is the function up here. So let me build around that and we can see it invokes the display function indirectly. That is for every element and it prints those elements out. Now as an exercise, go and write a display functor class and display the elements in the array that is within the print scores function using the functor instead of the function pointer, which will indirectly invoke a function. Okay, so ultimately we want to get the same sort of output, but instead of using a function pointer, we want to use a functor. Okay, I'll write the functor class. We have to overload the function call operator, and I'll basically do the same thing in the body that I did for the display function. Now what's nice about this is you can overload that operator and display different things based on what you pass in and how many arguments you have and so forth. But for this example, we'll stick to the single definition and we'll go and change the type right here. Okay, so we'll change this from a function pointer to a type display and have this parameter here, display parameter. And now within the for loop, we can go and invoke that overloaded function call operator. So I have that parameter here, display p for display parameter, and I pass in the particular element which we fetch in this way, and that is simply going to invoke that function right there. In the main function, we need to go and update what we want to pass in here, okay, where we invoke the print scores function. And if I build around, this should work fine. You can see those scores print out as we would expect. But what you can also do is, you can do this to create a temporary display. You can use the list style construction, or you can use the parentheses if you want. And that will construct a temporary object, which will work fine. We can pass that in and this will work fine here. Build around that. And you can see that prints out all of those elements now using the functor instead of using a function pointer as we had it before. For this next example, I have this function modify elements, and what I want to do is I want to pass in an array of victory points, so we can have arrow points, and we want to modify the elements within that array. Remember that we pass an array by reference, so this is not going to be const right here, this formal parameter, because we actually want to modify the elements within the array. So what modifications can we do in the elements within the array that we pass in? We'll have two functions defined here. We can square those elements. This takes in an integer. There's a formal parameter int p. It's going to return p times p. And then we also have an increment, which also has an integer formal parameter. What I'm going for here is I want the signature and the return type to match. The types in the formal parameter list and the return types need to match because I want to use a function pointer right here. Okay, so the increment function is simply going to return the parameter plus 1. So it's going to increment what we pass in by 1. Okay, in the modify elements, we have an array and we pass in the size as well. So we pass in an array and we pass in the size of that array. For the third formal parameter, we have a function pointer called the modify here. Okay, the signature is going to match that of the currently available modifications. We can square and we can increment. So in the for loop, what we can do is, for every element in the array, we go and apply a particular modification as specified, where we actually invoke the modify elements function. We do that using the function pointer currently, function pointer modify, and we pass in as an argument the particular element. So we fetch the element, we call the particular function indirectly with a square increment, and then we store the result back in the array. That again is for every element in the array. In the main function again, I have a size for the array, and then I have a victory points array. I pass in the size for the array. I specify some elements here, 1, 3, and 5. The remaining elements will be initialized to 0. Then I go and do this section right here. I print out victory points before modification. Then I go and print those out using a for loop. Console output victory points, and I pass in the iterator here. Then I go and modify those elements, and we'll start off with the increment. Okay, so again I pass in the victory points array. Remember again, we pass an array by reference, so we can make those modifications in here. So with the modify elements, we pass in the array size as well. And to get started, I'll pass in the increment. So it's supposed to increment each element within the victory points array. And then I go and print those elements out again following the modification. Build around this so we see what we get. We get victory points before modification 1, 3, 5, 0, 0. Then following the modification, we get 2, 4, 6, 1, 1. So we can see that the elements have been modified successfully, and it did apply the modification that we specified, which in this case was the increment modification. Now, of course, we also have square here, and we can specify, okay, we want to square those elements now. Build around that, and following the modification, those elements are now squared. Moving on, let's say we want to make this modify elements function more generalized. For example, let's say we want to remove the fp for function pointer prefix, so that we simply have a modify right here. Build around that one more time and that should work fine. Currently, we can apply these two modifications to the elements in the array that we pass in. For this demonstration, we are applying the modification to all of the elements within the array. This is just for demonstration purposes. You can have a function where you apply some modification to a particular element, but just to keep it simple, we'll modify all of the elements within the array. One more thing to note, I'll just highlight the statement here. To create a more generalized modify elements function, again, we don't want to make changes within the body of the function. And so what we have currently, we have this modify, which is currently the name of a function pointer, and we pass in the particular element that we want to operate on. So let's say the index here is 0, then of course we apply the modify operation on the first element. So let's say that is increment or square, and then we do the same thing in the next iteration on the second element and so forth. This is fine if we have something like increment or square right here. But what if we want to do addition or multiplication? But let's say we want to specify the number that we want to use for the multiplication, so for the product that we want to return. So you can start to think that, okay, we can do an addition functor or a multiplication functor, and then instead of having a function pointer right here, we can specify a functor to use instead. Eventually, we want to get to a point where we can pass in either a functor or a function pointer, because with the syntax, we can see that we can use both a functor or the function pointer as we have done up until this point. So let's just go and create a functor here. I will demonstrate using an addition functor, but of course you can create a functor for multiplication, division, and so forth. So we have a member. Again, what's nice about a functor is it can have a state. So when we construct the functor, we can pass in, okay, what do we want to add to the elements within the array here. Let's say we want to add 5 to those elements, then of course we construct the addition functor by passing in an argument of 5 for the constructor. Okay, the constructor takes in an integer, and we use that to initialize the member, so the state of the instance. And then I have the overloaded function call operator right here that also takes in an integer, and that's going to return the addition of the member plus p, whatever we pass in. We're going to use that right here. Okay, so what's going to happen is we fetch the particular element, let's say that is 1, that gets passed in here, and we do 1 plus whatever the member was, let's say that is 5, and we return that eventually, and we assign that to the particular element that is determined by what the index is. We have that functor. Now we have to change the type right here. And this is what I meant previously, so we change the type in the formal parameter list. But we do not have to change anything in the definition in the body of the function. You can see the statement is going to remain the same. This is what you want to do when you want to create more generalized functions. And now in the main function, instead of passing in the square, we can say what do we want to add to each element within the array. For this example, we'll add 5. Okay, so we construct an addition functor, we pass in 5, and if I build around that, you see what we get. We initialize those elements 1, 3, and 5, so that is before the modification. Then we pass in a functor, which we invoke to modify the element, so we get 6, 8, 10, 5, and 5 now, adding 5 to each element. And in a similar way, you can do multiplication and so on, basically binary operations. I'll scroll back up, and for an exercise, what I'd like you to do is, I'd like you to turn this modify elements function into a template. Once the modify elements function is a template function, the parameters are updated. We don't want to then make changes to the body or the parameters following that, because currently, let's say we want to pass in one of these functions, then we need to go and change the formal parameter, or we have to go and overload the modify elements function. And instead of doing that, we can simply do a template modify elements function. Again, the goal is to leave the definition of the modify elements function unchanged. We just want to pass in a different modifier and be able to create new modifiers that we can pass in, maybe a multiplication functor as I mentioned before, and so on. Go ahead, try that, turn the modify elements function into a template function, and test it out a bit, see if the function works whether we pass in a function or a functor. Okay, let's turn the modify elements function into a template function. Remember previously all that changed was the type, so we either had a function pointer or we were using the functor. So we have a type parameter and we specify that here, and then we go and use that, the parameter of that type, and we pass in the element. Now in the main function, I can pass in either a functor, and that will work. Build around that. That works fine. Or I can pass in one of those functions such as square. Build around that. And now of course you can start to experiment with other functions that will actually now work based on the definition that we have. But even with a simple example, you can start to see the possibilities here, the flexibility that you have with this. You can now use either functors or function pointers. We have a generalized abstract function that we can use on different sizes of arrays. Okay, we could pass in the size here, and we can specify which modifications to apply on the elements. So again, just a simple high-level example, but you can start to think of the possibilities with this. And that is going to wrap up the introduction to the functors. I hope you found this interesting, and I'll see you in the next lecture.